In this question, we have been given an augmented matrix and we're asked to solve the system. So I'm going to go ahead and just assign some variable names to these because that wasn't given to us. So just use the standard x1, x2, x3, x4, and x5. So one thing that we could do is actually just go ahead and write this as 3 equations right off the bat. So notice the fourth row is just entirely zeros, so it doesn't contribute anything. But we could actually just take this and, like, for example, write the third equation says x4 equals 1. The second equation says x2 plus 2x3 plus x4 minus x5 is -1. But then we'll have to clean it up a little bit because it's got the x4 and we already made a determination about x4. So you could do that, but I prefer to just do the row reductions in the matrix because it just cleans things up in a little bit more of an organized fashion for you. It does the same work of like those rearrangements you would do if you actually like wrote the equations right now. So I'm going to keep reducing. And what's missing is that this isn't in like completed row reduced echelon form. And how we know that is because we've got these 3 leading entries and we've got non-zero values in the same column. And so we should be able to use those leading entries to wipe those out, and that'll make our life easier. So I'm going to do that. It's always easiest to work left to right because of just the way the zeros fall. So for example, if I use this 1 to wipe out some things here, maybe I'll get some interactions when I make my way up that might bring some numbers back. So just work left to right. So I'm going to start by using the second leading entry to eliminate the -1 above it. And I can just add to get that. So I'll have 1 plus 0 is 1, -1 plus 1 is 0, 2 plus 2 is 4, 4 plus 1 is 5, 6 plus -1 is 5, and 2 plus -1 is 1. And then I will write the second row. And I'm going to be a little bit lazy and just not write the third row because it's a 0 row. And as far as a system of equations, 0 equals 0 doesn't provide us with any information. We don't need this. And so now I'm going to use specifically this pivot here to get rid of the 1 and the 5 above it. So that's going to be row 1 is row 1 minus 5 of row 3. And row 2 is going to be row 2 minus row 3. And so I'll have 1, 0, 4. All right, because I'm just subtracting the zeros from row 3, and then 5 minus 5, 5 minus 0, and 1 minus 5. And then I'm going to do 0, 1, 2, because it's zeros below, and 1 minus 1, -1 minus 0, and -1 minus 1. And then I am not doing anything to my third row. And so we should have this. And now what we'll want to do is just work our way backwards to establish what all of our variables are going to be. Now, before I start writing things out, we should note, again, we have these pivots. So those are going to be fixed. Our leading entries are pivots. So anything that doesn't have a pivot, we're going to call our free variables. And we're going to assign them parameters. So I'll let x5 be t. And I'll let x3 be like r or s or whatever letter you like. And then I'm going to make my way up. It doesn't totally matter at this point if you go up or down, but if you choose to not simplify as I did here with more row reductions, you always want to work your way up. So just for the sake of consistency, I'm going to work my way back up. So row 3 tells us that x4 equals 1. And that's just what it is. It has nothing to do with the parameters. So row 2 is going to be x2 plus 2, and that's x3, but we just said it's r. And then minus x5, which is t, is -2. And then if I do row 1, Same thing, that's going to be x1 plus 4x3, which is r, plus 5x5, which is t, is -4. And so yeah, these are actually all my answers. I'm just gonna go around and like isolate the x1, x2 and write them out in a nice order. x1 is -4 minus 4r minus 5t. x2 is -2 minus 2r plus t. x3 is the parameter r. x4 is 1. And x5 is the parameter t. And that's our solution set.